I was running low on original Raspberry Pi Picos, so I recently picked up my first Raspberry Pi Pico 2s as I saw they were on sale from Micro Center. I've used the original Pico for some simple RGB controls on keyboards, just to turn on and off the lighting based off of the reading from a light-dependent resistor. Since the Pico 2 is more powerful and has more RAM, I decided to try a more advanced RGB controller for this keyboard, the Alienware AW410K mechanical, as I haven't created a Pico-based RGB controller for it yet. The goal is going to be to 1. Pass through keyboard inputs from the keyboard through the Pico 2 to the connected computer. 2. Use a light-dependent resistor or LDR to adjust the lighting dynamically based on the ambient light conditions. 3. Allow individual configuration of the RGB LEDs on a per key basis. And finally, 4. To provide a user interface for the LED configuration on a web page that's served through the USB connection. I should point out that I've basically done 1 and 2 previously with the regular Pico, although the goal here will be to provide adaptive lighting with the LDR instead of just on and off control based on a threshold. So in this version, the LEDs will be brighter when it's in a darker environment, and the LEDs will get progressively dimmer as the room gets brighter. My previous projects also set all of the keys to have the same color, namely white, as I'm personally not a big fan of colorful RGB, but in this version, I want to at least have the option of setting a different color to each key. Although this is going to add a little bit of complexity to the code, in the end, it shouldn't be too difficult to implement at the cost of a bit more RAM usage on the Pico 2. The final feature though, a web page that's served over the USB connection, that definitely is going to require a bit more work to implement, as I've never used the Ethernet over USB feature of TinyUSB before. But from my previous web keyboard project, I'll be able to reuse the code for generating a graphical version of the keyboard layout on a web page that I can interact with, as well as the Websockets for sending real-time updates of the LED configuration. I'll start by making the physical device with the Pico 2, a USB cable, light-dependent resistor, and a regular resistor. In my previous videos, I've demonstrated how to connect the two ends of the USB cable to the Pico, so I'll fast forward through that process and just say that we'll attach a female socket that the keyboard is going to plug into, and the male plug that will then be used to plug into the computer. Then I'm going to put a light-dependent resistor on one of the analog to digital converter or ADC pins. A light-dependent resistor has a resistance value that changes with the amount of light that it absorbs. So it, combined with the ADC detecting the voltage on the pin, can be used to detect how bright it is in the surrounding area. The additional resistor acts as a pull-down to improve the accuracy of the ADC readings. For the programming, the first step is to make sure that the keyboard's inputs are passed through to the computer by the Pico 2. The tricky thing here is that many of these RGB keyboards present themselves as a USB hub with multiple devices connected to them. So in the past, I've needed to do some processing of those inputs into the Pico, figure out which ones correspond to key presses, and combine them to a single keyboard output that the Pico passes on to the computer. Instead, in this version, I'm going to configure TinyUSB so that the Pico 2 itself acts as a hub with multiple interfaces. Each of those interfaces is going to pass through one of the interfaces on the keyboard directly. This requires a bit more work up front when everything is connected to load the HID report descriptors for the individual interfaces on the keyboard, saving them to memory on the Pico 2, then having the Pico 2 connect as a USB hub with those interfaces configured with those HID report descriptors. The flip side is that the inputs can then be passed directly without needing any processing or conversion, which frees up some resources for the RGB controls and the web server to be run to configure the RGB lighting. Once I've checked that the keyboard works when plugged into the Pico 2 and into the computer, it's time to move on to the LED controls. We'll start by going over to OpenRGB to figure out the RGB control protocol. OpenRGB is a great resource for this, as they've reverse engineered the lighting protocols for a number of devices, and they're fully open source. So if your device is supported by their software, you can go into their source code to figure out how to control the lighting. Looking at the source code, we can see that within the controllers folder, there is in fact code to support the AW410K. And we can take a quick look at it. And note that the setting of the color consists of a few initialization messages sent as HID feature and output reports, followed by a feature report with a number of keys to be set, and then the individual RGB colors for each of the keys sent in a set of 65-byte messages. One thing to note is that when you're looking at the OpenRGB source code, they use a library called HID API, where the first byte, byte 0, is actually corresponding to the HID report ID. And then the remaining bytes are the actual report. On the other hand, TinyUSB passes the report ID as a parameter. And so what appears in OpenRGB as a 65-byte message is actually a report ID plus a 64-byte HID report. Each key on the AW410K is assigned a code or index that is needed to set its RGB values. So what I'll need is a database holding the key index and 3 separate 8-bit variables for the RGB colors for the red, the green, and the blue. To make it easy to identify what key corresponds to each index, I'm also going to include an easy to understand name for the key in this database. I'll save each key's information into a struct and make an array of these structs that stores the mapping for the key index and some default values for the RGB, and then implement the HID commands I need to set the colors for those keys. After a bit of coding and debugging, I am able to successfully send the default RGB values to the keyboard, which is just a plain white for everything, and have it light up each key in that color. Now is the tricky and also new part, at least for me. I'll need to add an Ethernet over USB interface on the TinyUSB device side of things, so that's the side that plugs into the computer. After a bit of research, it looks like the communication device class, a network control model, or a CDC-NCM, is the newest implementation of this and should have the widest compatibility among operating systems and devices going forward. So I'm going to go ahead and add a CDC-NCM interface on the TinyUSB device. This requires enabling NCM in the TinyUSB configuration file, as well as adding the NCM interface to the USB descriptor. So using the TinyUSB net LWIP web server example, we can see what needs to be changed in the files. And with a little bit of trial and error, the computer can now detect a new Ethernet device. Next, I'm going to set up a simple server through LWIP using the example provided to be able to test the USB Ethernet connection before adding the bells and whistles for a web page that allows for configuring the RGB settings. The example also links to a TinyUSB library with a DHCP and DNS server to run alongside LWIP. So I'm going to arbitrarily pick the 192.168.40.0 subnet for the IP settings and get that configured. For the MAC address, we're going to use the 02 prefix to indicate that it is a local only MAC address. And then we'll use the last 10 digits from the board serial number to make it relatively unique in case I plug in some other Pico or Pico 2 boards into my computer later. After getting the TinyUSB network interface to get an IP address assignment, we can go ahead and ping the web server to see that it works and load the address in a web browser to get the test page that I made. The next step here is going to be to create a web page for controlling the lighting. I'll need to lay out the keys on the web page to match the layout on the keyboard, and then I'll use a WebSocket connection to allow for real-time communication between the web page and the Pico 2. This will make it so that I can send commands to the Pico 2 to set the colors of specific keys, which will then be forwarded to the keyboard. But also it will let me click on a key on the web page and it will retrieve the current color settings for that key and display it on the page. This shouldn't be too bad to implement, but I did run into a couple of bugs with processing the set color command that caused the whole device to freeze. It took a little bit of time, but I did eventually resolve that bug. And at that point, I can go ahead and set the colors of individual keys and save them into RAM or into temporary memory. But that means that whenever I unplug the Pico 2 and it lost power, it would lose those settings so that whenever I plugged it back in to give it power again, it would reload the default colors instead of the last used colors. So the last step here is to save the color configuration from RAM into the persistent flash. Most examples from the original Pico save data to the last block of the flash memory, but the E10 errata on the Pico 2 means that the last block is overwritten whenever new firmware is flashed, and that will erase those saved settings. So taking note of this, we need to move the save address to the second to last block instead, and we can save the database with the individual key color settings to the persistent flash in that location. And then whenever we power the Pico 2 on, we will first look at that address and see if there's data saved there, and if there is, load it back into memory so that we will be able to preserve those color settings across reboots. With that, we're done. We have a Pico 2 set up to control the RGB settings of our keyboard, and we can configure the color for each key from a web page served over the USB connection. The advantage of this, of course, is that we don't need to install any software onto our computer to configure or change our RGB settings, and the web page to do that should work on any operating system. If you have a different keyboard, you can take this framework and modify the HID reports for setting the colors to the protocol used by your keyboard. In general, most keyboards that I've seen work in a similar manner where it has a number of initialization packets that are sent, followed by a sequence of packets that have the individual RGB settings for each key in them. What changes is the specific format of those messages, and so you'll need to figure out what that looks like for your keyboard. If your keyboard, though, is supported by something like OpenRGB or in some other project, you should be able to take a look at the source for that project to then be able to figure out how to program the protocol for your keyboard. Also, I'm really only interested in solid colors or static colors, so I didn't do anything like animations or transitions or that kind of dynamic effect with the colors, aside from dynamically adjusting to the lighting from the LDR. But if you wanted to add your own effect, that should be possible by writing a routine that updates the RGB colors at a specified interval. So if that's something that's interesting to you, then there's definitely headroom within the Pico 2 to be able to add that kind of feature.